All right, welcome back. We are on 21. So it says, which of the following expressions is equivalent to this thing? They just want to know which is the same. So I see parentheses. I'm going to go ahead and distribute. So I get 3a plus 3b. And then negative 2, distributing that in, is negative 2a plus 10b. We do have plus because the negative makes it positive. And I have 3a minus 2a would be 1a. And then 3b plus 10b is 13b. So your correct answer is E. It's a distribution problem. For number 22. It says in the figure below, all the small squares are equal in area, and the area of rectangle ABCD is 1 square unit. Right, so this whole thing is 1 square unit. It says which of the following represents the area in square units of the shaded region. So if this whole thing is 1, then this is like 1 by 1 kind of thing. And that goes all the way to the edge here. So this, we know the area is length by width. So we have 1, 2, 3, 4, 5, 6, 7, 8. We're going 8 out of the 9 blocks going that direction. And then the height here, we have 1, 2, 3, 4, 5, 6 out of the 7. And we know that we would do base times height, and we would multiply them together. So I'm going to look for the one that has these two together, which would be K. My answer would be K. This one says, Marie is building a kite. In a drawing of her kite shown below, AB is equal to BC. So this is equal to this. AD is equal to DC. AD and DC are equal. So I'll put the double tick mark there. The measure of ABC is 80 degrees. So this right here is 80 degrees, which really means like this part right there would be 40. And so with this one, 40 degrees. It says the measure of ADC is 50. So this would be 25. And this one would be 25 degrees. They want to know the measure of BAD. So BAD. They want to know this measure here. So if I make this a little bit bigger, here's my kite. I know this is 40, and I know that kites meet at 90-degree angles. So if this is 40, then 90 and 40 make 130 degrees, minus the 180 for this triangle right here would give me 50 degrees left over, 50 degrees for that corner there. And then I know over here, I had this whole thing was 50, so this part here would be 25. I know this is also 90, so 180 degrees minus the 90 degrees minus 25 degrees. I can do that in my calculator, and I would get 55 degrees. Oops, sorry, 65 degrees. So I know this over here is 65. So if they want to know B, A, D, all the way, this one here, they want to know these two angles together, the 50-degree angle and the 65-degree angle. All together, they would make 115 degrees, which is D. If I was just looking at the picture, I know that it's more than 90 because it's like wider than a straight angle, so it's not A, B, or C. So it might be 130, but definitely not smaller. That is 23. 24 says the angles below are similar. This little like squiggly means similar, means that they're in proportion to each other. So which of the following is an expression for the area of ABC in square inches? So if I know that they're similar, I can figure out what the factor is, how much we have to multiply by. So this is 2 times what would give me 4 times 2. So then in this case, in order to get to this one here, I'd also have to multiply times 2, which would mean that this is 6. Right? So if I want to know the area of ABC in similar inches, ABC is this triangle over here. I know that the area of a triangle is 1/2 base times height, or base times height divided by 2. So I have my base of 4 and my height of 6, and I still have the 1/2 there. So in this case, they don't even want us to solve it here. We're just looking for the one that matches what we wrote, and that would be K. This one here. That is 24. Finally, 25 says, the interior of a rectangular shipping crate has dimensions 2 feet by 3 feet by 6 feet. So rectangular shipping crate looks like this, 2 feet by 3 feet by 6 feet. The crate will be filled with cube-shaped boxes whose interiors have dimensions 12 inches by 12 inches by 12 inches. So basically like 1 foot by 1 foot by 1 foot, because there's 12 inches in there. Given that no box can extend beyond the dimension of the crate's interior, what's the maximum number of boxes the crate can hold? All right, so we're thinking about how many of these boxes could go in here. And this is like 1 foot cubed. 1 foot cubed. So if we can figure out how many feet cubed are in here, then we could figure out how many of these fit inside. So in order to do volume, I know it's length times width times height. So I would do 2 times 3 times 6. So 2 times 3 times 6 would be 6 times 6, or 36. So my volume is 36. So 36 feet cubed are in here. So how many 1 foot cubed box would fit into 36? That would be 36 of them. 36 feet cubed. So important to know the volume formula. This is for rectangular prisms, or basically like pools. Often they talk about, like, I don't know, anything that's a rectangle space. Right, that's 3-dimensional. Right, so rectangular 3-dimensional is going to be length times width times height. Ooh, that's 25.